Are we ready to go? I guess so. We're going to futz around with our demos a little bit this morning. Their video equipment doesn't want to talk to our video equipment, so they're going to have a conversation and see if they can come to some agreement. This morning, we're going to have a university session entitled Important Android Stuff, which is a title that we came up with when we had no idea what we were going to talk about at the conference. So we like to submit titles and abstracts that are sufficiently vague that we can make it up a week beforehand.
The day before.
Or the day before, or sometimes the morning of. So today, what Important Android Stuff means is that we're going to have two halves. The first half is going to be about animation because I can't really shut up about it. And also because, frankly, there's a lot of ways of accomplishing animation on Android, and sometimes it's confusing to know what to use when. So we thought it'd be good to have an overview of the vast array of possibilities and particular times when it might be useful to use one or the other of the techniques. We have lots of demos and code to walk through, and hopefully we'll give you a better understanding of how this stuff works in general. That's the first half. We'll break whenever that ends, which is basically when we stop talking. We don't have a specific time yet. The second half, we decided a couple weeks ago would be about tools and probably some tips thrown in at the end.
Yeah, and as we were working on slides, we realized that it will be mostly tips and maybe a tool.
Yeah, so lots of tips, lots of graphics performance and UI tips, techniques to write better Android applications, which is what it's all about. So let's dive in and see if our demo devices can participate with us. We work on the Android team at Google, specifically in the UI toolkit team, doing animation, graphics acceleration,
performance,
and random stuff that happens to come up during the pressures of any release. There's some Twitter handles. We tend to post on G+ too if you follow us there, if you want to. So, various types of animations, ways of accomplishing getting things to move on the screen. If you are currently writing for releases prior to Honeycomb 3.0, then you're probably familiar with the old, what I call the ViewAnimations system. It's in the package that's android.view.animation, and there's basically a handful of things that allow you to move views around on the screen. WindowAnimations builds on those. That basically uses the same approach, but specifically for transitioning between activities or between windows of sub-activities. And then there's Drawable Animations. There's a couple of specific classes that allow you to animate rendering on the fly of shapes, bitmaps. And then there's the new Property Animations system, which came along in 3.0 and which we've been adding to since then. So we'll go a bit deeper into that because that's kind of the future of where animation is going, sort of a more flexible and robust system.
So we're going to start with the old animation system, and that's the animation system you have to use if you're targeting Android 1.0 all the way to 3.0. So in 3.0, we introduced this new property animation system that Chet is going to talk about more in details later. So it's good to know about those animation classes. So how many of you have used those classes directly in code? Because you can also use them from XML. Okay, not too many. Those are the animations we use, pretty much all over the UI that we use to do fades, to move things around. Launcher used to use them a lot to animate the shortcuts when we delete them or things like that. And this animation system is fairly limited. You can only do any of those 5 animations. So you can do fade in and out. So that's an alpha animation. You can move, you can scale, you can rotate, and there was something called the animation set. There is something called the animation set that lets you combine all those animations together to create more complex animations. All those animations are very useful if you want to do very simple visual effects on screen. They are less useful when you're trying to come up with your own animation. So for instance, if you're trying to do a 3D rotation, you have to create your own animation subclass. You have to understand how to create a subclass. You have to override a bunch of methods, use mess with matrices. It's pretty complicated, and really you should stick to the base animation classes. I think I showed, there's an API demo in the SDK that shows you how to create a 3D rotation, but that's about all you can do. If you want to do anything that's not animating a matrix or an alpha value, you cannot. Like those animations are very, very, very simple. One of them can actually be used in a slightly different way. So the alpha animation just generates a value between 0 and 1, and you can use the output of the alpha animation just as some sort of a timing information. So you can use this value between 0 and 1 and apply it to anything you want. For instance, the progress bar on Android uses internally the alpha animation. So when we have an indeterminate progress bar, we play this little animation inside the progress bar. It's like a little diagonal pattern that repeats. We use an alpha animation internally to just generate those values between 0 and 1, and we use those values to just move things around. So, like I said, fairly limited. They work, but they're not very interesting.
So let's take a look at some code where we actually see how these classes are declared. So I'll launch things from here, and then we'll see it in the little picture there. So view animations.
And we're terribly sorry about the demos. We wanted to use HDMI, so you can see the demos run at 60 frames per second. The video camera we are using has a very low frame rate, so don't worry. The animations look a lot better on the device. You can come see them later if you want.
What kind of frame rate? Yeah, the focus is not that great either, but we'll get by. The interesting part about all these demos, frankly, is the code, not what's actually on the screen. That just shows how things work. So we have alpha animation, we have translate, which is for moving things on the screen. Look at that, it's even animating there. Thank you very much, well done. We have things that can rotate buttons because everybody needs rotating buttons. We can scale things. And then we have animation set, which is for grouping things, so that sort of runs all the animations together. The checkbox at the top, so we'll see a little bit of code and see what's actually going on here, but basically there's two alternatives with the old animations as well as the new animations. You can either declare stuff on the fly in code, create these objects and then run them, or you can create them in resources and then inflate the resources and run those. And in this case, we're basically doing the same exact animations in most of these cases, except they're inflated from XML resources instead. So if we take a look at the code for this, we'll pull that up. You can sing a song while I do this. We're going to have a lot of these segues.
I don't think you want me to do that.
Okay, so we've got those fantastic buttons there that we declare. Alpha animation, you declare an alpha animation. You give it the start and the end value. And I happen to set durations of 1,000 seconds here, 1,000 milliseconds, just to give it a little bit longer to run on the screen so we can see the exciting duration.
Setting the duration is actually one of the differences between the old animation system and the new one. In the new one, setting the duration is optional. We chose a default duration that makes sense for most of UI animations, so you don't have to worry about it. But with the old animation system, you have to specify duration. If you don't, you're going to have an animation of 0 seconds, which is not terribly useful.
Really fast. Fantastic frame rate on those. Okay, translate animation, very similar. So you declare, let's see, I would really love to see the right-hand side of the screen. Oh, it's because my display resolution changed. Here we go. So we declare these values here are basically saying, I'm going to give you a value, and here's the way to interpret that value. So relative to parent, I want to translate the width of the parent, and I want to translate 100 in Y units. Again, we set the duration. Rotate animation, we're going to be rotating relative to self means basically around the center of the object, and we're going to rotate 360 degrees in a full circle. Scale animation, we're going to be scaling from 1 to 2, both in the X and the Y direction. And then animation set, we simply add the animations above. They're all independent. They're not targeted at a particular view in and of themselves. So we can add the animations to this set and then target the set at a particular target. So we set up the animations here. This loads the things and then starts them. So this will basically just say start the animation on the particular view. And here it takes either the animations that we declared above or the animations that were declared in resources. So we can take a look at those.
When you create animations in code, be very careful. An animation object is stateful, so you cannot apply the same instance of an animation object to several views. I've seen applications try to do that, and it might work, but as you change your UI, you might run into issues. So make sure you create a new animation object for every view that you want to animate on screen.
The alpha animation here, it's pretty straightforward. The values that you see in XML map pretty closely to what you create in code as well. So we have a from alpha and a to value. To alpha, we have a duration of 500 milliseconds here, sort of arbitrarily. Rotate animation, again, similar properties as we have elsewhere. We're going to rotate 360 degrees around our center. 50% of ourselves. Scale animation, we're going to go to an X scale of 2 and a Y scale of 2. Set animation groups several different animations together, and then it's going to run it on the same target. And then the translate animation, again, very similar to what we're seeing in code. So fairly straightforward.
And whenever you can, we recommend that you use animation resources because that means you can customize the animations based on the configuration of the device. So landscape versus portrait, different languages, or even more importantly, between the tablet and the phone, you might want to play different animations, or you want to adapt the durations. A duration that works on the phone for that size of a display might not work on the tablet. It might be too fast, it might be too slow. So don't hesitate to use the different configuration qualifiers for resource directories to adapt your animations to the target.
And there's also different styles that you can apply for different durations, and you can theme these to have, I don't know, really painfully long animations in a particular theme if you're really into that. So here's some tips about using the view animations. They're really good at doing the specific tasks that they do, but as Romain was saying earlier, they don't go really far beyond that. If you want to do a custom animation or you want to animate a custom object or type, then you're sort of forced into the hack of, well, you know, alpha animation will give you an arbitrary value and then you can use that. But it's important to understand sort of how they work and some of the limitations so that you can use them effectively. So one of the things that people run into is that the old animations, the old view animations, don't actually change the object themselves. What they change is where and how that object is drawn. And there's a very important distinction. If you can imagine the translate animation that moved the button to the right, well, I could animate that thing and then I could actually have it hang out there on the right using a fill-enabled property we'll talk about in a second. But to click the button, you actually still need to click on the left, right? Because the button is actually still on the left. It just looks like it's on the right. So really, the old view animations are not about animating objects. They're about animating properties that the rendering system will use to actually draw those objects on the screen.
Yeah,
and
you should think about them as transient animations. You should play the animation, and at the end you have to move your object yourself by redoing a layout or things like that. Do not use the animations as a way to apply transformations on your views forever. We'll talk about fill after, fill before, and fill enabled, but I've seen a lot of applications who are actually setting an animation that has no duration, or they don't start the animation, but they just use the animation as a way to transform the view. But if you do that, like Chet said, well, the view is not where you think it is, and the user cannot manipulate the view, which is not useful.
right, so yeah, transient effects, not homeless effects, but temporary effects. So basically, they do the task that you want them to, but it's when people try to use them sort of more robustly to actually move stuff on the screen and have it live there that they kind of hit some of these boundaries. You can manually drive the animations, and this is actually what the window manager does for window animations, where instead of setting it on a view and having the view sort of magically re-render itself over the time, you can query in with particular values and say, well, give me your current transformation. And this is useful in some situations if you need something more flexible. With the old animation systems like the progress bar.
Or even if you're writing a simple game or custom view and you need to play animation, instead of writing your own animation code, you can use those classes directly, and you can call a method called getTransform, and you just pass the current time, and it will return you a transform. So a transform is a matrix plus an alpha value.
One of the cliffs that people have run into is with the fill flags. They're a bit tricky to understand, and the docs probably don't help a lot there, and we tried to clean up the docs a little bit since. And then I actually wrote a whole article about how the things actually work internally and how you should sort of build a mental model, because it's not obvious simply from reading the names of the fields. An important thing to note here is the fill before property always kicks in. So if you set fill before, it basically means set this property immediately, even if I haven't started animation, even if there's a start delay until the animation actually kicks in, I want you to set that value immediately, like set it to a value of alpha 0 before we actually start the fade in. Fill after, on the other hand, will only kick in if you set the fill enabled flag. And this is not obvious, and I'm sorry about that. But as long as you understand it, you can do what you need.
It gets even more confusing if you don't want fill before, the fill before behavior. You have to set fill enable to true, so you can set fill before to false.
So we could have called it fill enabled disabled, but then it might get a little more confusing.
And the reason for this mess is we had only fill before and fill after, but there was a bug, and for compatibility reasons, we could not fix the bug without breaking existing apps, so we had to introduce that fill enabled. And that's another reason why you should not use the old animation system if you can, and use the new one instead.
Yeah, I would like to say here for the record that we do not have these fill flags on the new animation system. And the other point I want to make is it's important to understand how the rendering system works, because the old view animations were all about the rendering system. All of the logic and the timing and the drawing of these objects is handled in the view system itself, like during the draw methods that the views are handling. And understanding how that works is kind of a good idea if you run into problems. So for instance, one of the things that I have seen bugs in applications is when we started enabling hardware acceleration, we go through a lot of effort to make sure that we don't redraw stuff that actually hasn't changed over time, which means that if you have a view that hasn't changed, well, we have concepts we call a display list that we know how to draw that view. So as long as you don't invalidate that view, we're not going to change the display list. We're just going to draw what it used to have. Right? So no longer can you do things like invalidate somebody way up in the view hierarchy and expect this guy to pick up those changes and actually re-render itself. Instead, we're just going to output the old thing. So all of that's fine. That's normally just about rendering. But in the animation system, that means that the parent of a view is the one that's going to draw the view with its animated changes. Right? This means that if the parent doesn't get invalidated for some reason, we're not going to start the animation. We don't actually know to run the animation unless that view parent gets invalidated. This is normally not an issue for you if you set an animation on a view, if you start an animation, we handle that for you. But when people try to manually drive the animations, it can cause some weird bugs because the rendering system is so tightly integrated with the old animation system.
And if you want to know more about all these issues, we gave a talk in 2011 at Google I/O where we explained the new hardware accelerated model and display lists and how they can affect your applications. But hopefully you're not running into any issues with that.
Window animations are built on the old view animation system because that's what we had at the time. And the window animations will sort of create these fades and scales and rotates and drive them manually on each frame, say between transitioning between activities. So when you launch an activity, we're at least on the current platform, we're doing a scale and a fade between possibly the old activity and certainly the new activity to sort of give you this transition view of one activity to the other.
Yeah, and the window animations are not just for transitions between activities. It's any window that you have, you can animate. So if you have a dialog in your application, or if you use an instance of pop-up window, you can specify your own animations for that dialog or that pop-up window. For instance, if you've used autocomplete text view, you start typing text in the field, and you see a drop-down with suggestions for auto-completion. Well, that drop-down is just a pop-up window, and we have custom animations for that window. So you can control that the way you want with your own windows.
Right. So we have a system in place for us doing sort of standard transitions, but you can also enable window animations for your own activities. There are ways to enable this for the top-level activities so that you can get custom animations going in and out of those. We would prefer that you not do that because the ability for the user to see a consistent UI as they launch different applications across the device is kind of important, right? If every activity has its own funky animation coming in, that's probably not giving a great experience. So the stuff that I'm going to talk about here is how to enable window animations for sub-activities. We think it's fine. Once you're actually inside of your activity, what you're doing is you're transitioning between dialogues and pop-ups and sub-activities. That's good. You can create your own custom feel inside of that sandbox. But going outside of it, then it tends to create a funky overall experience. So as you transition, if you're in your main activity and you're going to some sub-activity, you're going to get a default window animation, which is going to be the same scale fade that we have across the system. But you can change that with a couple of different approaches that we'll see in the code. The new approach that's enabled in, as of I think 3.1, is there's an object called activity options, and you can set these animation parameters that tell it how to transition into a sub-activity and then back out of it. And there's actually two sides of every animation. You want to declare an animation that's going to tell it how to animate the new sub-activity in, as well as how to animate the existing activity out. And then when you go back out of your activity, then you may want to animate, may want to have a custom animation to get back to the main activity. So let's see some code. The new object as of 3.1 is activity options. There's actually 3 different ways you can declare animations here. There's make custom animation. You're basically declaring these resources. Now, one of the things that's important to note about window animations is they're only resource based. So before with view animations, we saw that you could declare animations on the fly in code and then launch those. That doesn't work with the window animations. We need to be able to declare things in one process that are then executed in another, and we do that with
It's mostly
resources.
for security reasons. The animations are executed by the window manager, and the window manager runs into its own process, and we don't want to run third-party code in that process. We don't want an app to be able to take down the window manager or do bad things with it.
So there's no callbacks into your code. Instead, you just declare the animation resource, tell it about the timing, the values, and the properties that are going to change, and then the window manager takes care of all the details. So you can make custom animation with these resources. You can also do 2 new things as of, was this 4.1? Around thumbnails, where you can scale into and out of, applications.
So here's an example. When you bring up the list of recent applications, when you launch an application from recent, we play this scale up animation from the thumbnail, and when you go back, we have this scale down. And that's achieved through this new API. That Chet was just showing you. Make thumbnail, scale up animation. So you can use that in your own application if you want to do similar effects between your activities or between your own custom windows.
So all of that is about getting into the sub-activity, and then returning from the sub-activity is you would use the prior approach, prior to 3.1, which is this call to override pending transitions, and that tells it how to back out. So let's take a look at another demo. We go down to window animations, we'll run this. So we have 4 buttons here that launch into an activity. So by default, you're going to get window animations between your activities and sub-activities. So we get the scale fade thing that you're used to from launching any activity on the system. You can instead declare custom animations to tell you how to animate to that sub-activity, and then do that override pending transitions to back out of that activity. Or you can use one of the new scale things. The 2 buttons at the bottom do that. So we're scaling from the button there, and then there's another option to say, well, use this bitmap to scale up from, which is a really horrible effect. And what you would actually use, this last one here, if you look at it really closely, or even squinting, you can see that it's doing this horrible text scaling, which Roman begged me to fix, but I didn't get time to. What you would usually use that for is the case like recents, where you're scaling from one bitmap, one image, like a thumbnail image of what you're going to into the sub-activity itself. So if you were like launching into a picture view, or well, you may have a thumbnail of the default picture that you're going to see in there. So we can take a look at, again, some code. So we have the main activity, window animations. When you click on the default button, all it does is launch an activity. And that activity is this one here, which doesn't do anything at all, right? So this is why you get the default system behavior, because you didn't tell it to do anything else. When you click on that second button down that did the slide in of the sub-activity and slide out of the parent activity, and then back, then we launch this other activity called animated sub-activity. And before we launch it, we're going to create this bundle. So activity options, make custom animation. We're going to grab a couple of resources here for the slide in of the new sub-activity and the slide out of the existing activity. And those are in the resources directory. So slide in left is just a translate that says I want to move all the way in from off the screen onto to x equals 0 for 500 milliseconds. And slide out left is going to move, it's going to slide the parent activity from 0 off to halfway off the screen, and by that time the other window will have covered it and it goes away. And then the third button down did one of the thumbnail scales, so it does a make scale up animation and just gives it the location and size relative to the current view, which is the button that's launching it. So it's going to scale up from that into the other activity. and then the final one down there gave it a bitmap to start from, which was a bitmap of the button itself, and then does a crossfade from that bitmap over to the full-size sub-activity along the way. One important thing to note is we built in this capability to scale up from these thumbnails and give it, size and location, the recent launch effect. It's not possible to actually go back. It's a little bit trickier to figure out, well, what is the thumbnail that you're going to, and how do we interpret that? So right now, you can do the custom animation to launch from the size and the location, or this optional bitmap thing into the sub-activity, but then getting back from the sub-activity, you basically just have the old system of override pending transition that doesn't have the option for the thumbnail. So it's a bit asymmetric in that particular case. Some of the tips, don't overdo it. This is sort of a tip for animations in general. You can get really wacky with these animations. Please don't. Your users will thank you. In particular, don't mess with the main activities. Let's keep a consistent UI across the platform. And the default animations are decent. We work pretty hard at doing things that are subtle. It helps the user transition from one state to another. So there's no particular reason why you need to change this. Some animations want a custom feel and then go for it. On the other hand, UI consistency is probably a nice thing in general. Scale-up animations, as I said, are one way you can scale up from a bitmap, but going back, it is asymmetric, so you need to use the normal override pending transitions that don't have the thumbnail or bitmap options. And then finally, the activity options, these custom animations and thumbnails are new in 4.1. If you're writing code for prior to 4.1, then you can also use the override transitions that we saw in the sub-activity. That declares the animations to get back to the main activity. You can actually use the same API to get into the sub-activity as well. It doesn't provide quite the same level of flexibility as the new approach, but if you're writing for older releases, then you can certainly use that. Drawable animations. Want to talk about these?
Yeah, so drawables are most often used as backgrounds for the views. So all the default widgets have a background drawable. For instance, the button, you have this button-looking background. But drawables can do a lot more, and we have two particular drawables that are animation capable. The first one is mostly used to do crossfading between two other drawables, and it's called the transition drawable. It's very simple. All you can do is, you have drawable A, drawable B. You can start a transition from one to the other. It will crossfade between the two. At any point during the animation, you can reverse the animation. And if you reach the end of the animation and you start the transition again, we'll go back to the first drawable. So it's very simple, and it can be used for simple changes in your application. The other one is called animation drawable, and it's more like, so you have a bunch of images, and we're just going to show one image after the other, and you can specify what amount of time to wait between two images. So it's often used, I've seen it often used by games if they just want to play animations for the main character. They just have a bunch of frames of the animation, a bunch of sprites, and they just switch from one to the other. They're very easy to use, but again, very limited. They don't give you much control, and I think Chet didn't really like the transition drawable when he started using it. Transition drawable, for instance, was used for a long time in Launcher when you picked up a shortcut and you moved it over the trash can to delete the shortcut. There was a small animation playing to turn the shortcut red, and to make it look nicer and more natural, we had the transition between the normal shortcut icon and the red version of the icon.
A couple of things. So the animation drawable, the keyframe, if you're going to implement an animated GIF of your cat, that's probably the class that you'd want to use. I think that's the main use case for animation drawable. Transition drawable, one of the cliffs that I ran into with this was I was going to use it as a transition effect between, like in a picture viewer as I went from picture to picture to picture. It's really about two images. And once you get into like having several animations that you want to transition to, then you're going to sort of change the state of the view along the way to get from picture to picture. It's a little bit brittle. It's really about crossfading between specifically two images. Its subclass is often a more general class, but the crossfade capabilities itself are sort of embedded around the concept of two.
Animation is useful in the context of the UI toolkit if you want to have a little program progress indicator. It's a very easy way to do it. So if you've seen our progress indicators, you know, those rotating little circles or those crosshatch patterns, in some versions of the platform, we simply use an animation drawable to run those. The big drawback of animation drawable is that we have to load all those frames in memory. We're not very smart about it. So if you use very large images, we have to load all those images, and it's going to take up a lot of RAM. So be careful with it. Try to keep it, you know, to use it only for short animations with few frames and small frames.
Little cats.
Little cats.
Kittens. Very good at kitten animated GIFs. So let's see how crossfading works. All right, so this is a really ugly UI. I'm fantastic at those. So basically 2 bitmap drawables that we're crossfading between. One is red, one is green. Not terribly interesting. Let's look at code instead. It's a little better. So we create a couple of bitmaps of a certain size. We draw colors into them. What did I tell you? I did not lie. There's red, there's green. We create some bitmap drawables. These are going to be the 2 things that we transition between. Then we create the transition drawable that has this array of drawables declared with it. And it's basically one drawable that kind of has 2 drawables inside of it. And then crossfading is about saying, okay, animating between one and the other. You can think of them as being stacked because basically they are. And what you're animating is the alpha value of the one on top. So start transition basically fades in the one on top. You no longer see the one behind. And then reverse fades out the one on top.
You know, you could have used color drawables.
I've heard that you can use color drawables. Shut up.
Next time I'll check your code before we show it.
All right, so here's the fantastically complicated way of crossfading. When I wanted to go from the red to the green, I would say start transition, and then I would set this internal flag. There's not really a way to query what is the one that you're currently showing. This is part of the brittleness that I found when I was working with this was it doesn't really store the state. What it does is does the crossfade that you tell it to do. So you just store the state yourself. You say which one is the one that's currently opaque that I'm showing people. So you set that flag, say start transition, it transitions there, and if that is the one that's currently showing, then instead we say reverse transition. It just goes back and forth. Not terribly complicated.
Yeah, and reverse transition doesn't start the animation over. It picks up at the current point and computes a new duration to repeat exactly the part of the animation that was already played but backward. So it's very useful. That's why we use it in Launcher, because if you have user interaction and the user tries to cancel the animation, we'll quickly do the right thing.
So keyframe animation. I didn't have any pictures of cats.
Thank God. Oh, it's your son instead.
I have this rock star instead. So if you tap it, that basically starts and stops a looping animated GIF.
And that's not the video camera, that's the frame rate we actually get on screen right here.
So I didn't have cats, but I did use my son because he's smaller, just to optimize on the bitmap size.
So remember when I said don't use large bitmaps? So don't do that.
All right, on to the code. Keyframe animations. I sort of hard-coded these drawables to load in. You can be a little more sophisticated. I tend not to be in my demos because that's not really what I'm showing. We load in, we create these bitmap drawables, and we have this image view that we're going to load them into, and we create an animation drawable that's basically a superset of all these drawables that we're going to have, that we're going to show over time. And we're going to add frames, and as we add frames, we say, okay, use this drawable and show it for, in this case, 150 milliseconds. So if you're doing something really complicated, like a kitten animated GIF, then you would find out from the animated GIF how long, what the duration is of each frame, and then pass in as that parameter. Set one shot false. I wanted this thing to loop over and over again because it's more entertaining. And then we simply set the image drawable on the image view, and away it goes. And then tapping on this thing stopped and started the animation. And that's it. This is just a utility method for loading the bitmap drawable.
So property animations, I think I already told that little story, but there was a bug I opened pretty much when I joined Android six years ago. because our animation system, like you've seen, is pretty simple. It's useful, but it cannot do much. So we wanted to do something more flexible, something that can animate any property on any object. I never had the time to do it, so hopefully we managed to hire Chet, and he did it for me, which was great.
Which is scary, because they could have just fired me after I finished that. Fortunately, they let me stay.
I thought about it, but... So this new property animation framework is available as of Honeycomb, so Android 3.0. There is out there a couple of ports of that animation framework to older versions of Android. One of them is called 9 Old Android by Jack Wharton, and Jack is around here this week. He has a talk, so if you have questions about his port, you can talk to him. One of the reasons why we never did a back port to earlier versions of Android is, as you will see, this animation system animates properties on objects. And the problem is that in all the older versions of the platforms, we don't have properties to animate on views. We don't have view.set alpha. We don't have view.set rotate x. We don't have ways to do anything useful with that animation system. So we could give you the API, and then you would never use it, because it's completely useless by itself.
So in fact, 3 weeks after I got there, I sort of hacked on this thing, and I had a prototype, and I checked in this thing. It's like, great, we have property animations. Now let's animate the views which have no properties. I couldn't actually do anything with it. I could, system out print lines, some really interesting stuff into Logcat, but that's about as far as.
But the good news is that this animation system is pretty well decoupled from the rest of the framework, so it's pretty easy to just grab the source code, and you have to make a couple of changes to make it run on older versions, but there's nothing major in it. This has changed a little bit in Jelly Bean, in Android 4.1. We now use an internal object called Choreographer that lets you synchronize your animations with the refresh rate of the display. So it's going to be harder to backport the animation system. Anyway, so we have a bunch of objects, and we'll talk about them one by one. So we have the ViewAnimator. This is the base class. It's just a timing engine. It's pretty dumb. We have the ObjectAnimator, and this one is one of the most interesting classes. It actually knows how to animate properties on an object, on an instance of any class. So usually you use it to animate the properties on views, but if you have your own objects, they don't have to be views. They don't even have to be visual. You can animate those properties. Animator Set is very similar to Animation Set. We just gave it a different name, so it's not confusing. You can just bundle up a bunch of animations together, and you can decide when if they run in parallel, if they run in sequence, or you can mix that up.
Actually, if you're used to Animation Set, hopefully Animator Set is a little more flexible. The way that you build these things up is
it's less confusing, and it works.
It's less confusing, but in particular, the old Animation Set basically let you play everything all at the same time. And if you wanted things to sequence one after another, you would do that with durations and start offsets. Animation Set is about playing things either at the same time or sequentially. Or you can also have start offsets. So it's a little bit easier to structure a more complicated choreography of animations.
It has a notion of dependency, so you can ask an animation to run before another one, or after another one, or with another one, and we'll figure out when to start them. All those animations, you can create them from code just like before. You can also create resources just like before. In 3.2, was it in 3.2 VPA?
Yes.
Yeah, in Android 3.2 we introduced a new class, and we'll talk about it because this is actually how you should do most of your animations in the UI. It's something called the ViewProperty Animator, and you will see it's a very, very simple API to create animations very easily. And finally, something that's not very used, and it should be used a lot more, I think. It's called layout transition, and lets you create very complicated transitions in your application. If you remove a view from a container and you want all the other children to move around to take their final position, you can use layout transition to do that automatically, and we'll have a demo of that.
One line of code.
Well, not even code.
Really, really long line. No, actually,
it's XML.
It's basically one line of code or XML. So value animators, as Romain said, is the base class. This is kind of the meat of the whole animation system. It's the timing engine that everybody else built on. ObjectAnimator adds the important capability of animating specific targets with specific properties, but value animator is the guy that's in charge of running the timing engine. Give me a duration I'm going to run for that long. Give me the start and the stop values, and I will calculate the values in the middle. Tell me how to interpolate those values if you want to accelerate or decelerate or have some custom timing. and tell me how to evaluate them. So you can actually give me custom objects like a data structure. It can animate anything as long as you tell me how to interpret those objects. Then ViewAnimator takes care of all
and what's
those
interesting
details.
about ViewAnimator is that once again, if you're writing a rendering engine of some kind or a game or basically anything that's not using our APIs, you can use ViewAnimator as a generic timing engine.
Which we may see later. There's a fantastic animated sheep demo that is animating several things on the screen at the same time. In general, ObjectAnimator or ViewProperty Animator are an easy way to animate things, but if you're doing several synchronous things at the same time, I found it easier to use ViewAnimator in this case, and just basically get a timing pulse event and then add a listener and say, okay, tell me when there's a new animation frame, and then I go in and calculate a bunch of values and invalidate, and away I go. Custom interpolation I talked about, and arbitrary types. Lifecycle events are more important with ViewAnimator than other animators in particular. You may want to know when things start and stop so that you can synchronize these events with the rest of your application. But for ViewAnimator in particular, you also want to add yourself as an update listener because it will calculate the values, but it won't do anything with them. It doesn't send them into target objects. Instead, it sends out update events to any listeners, and you plug into those update events and say, okay, now we're in a new animation frame. I'll get your animated value, and then I'll do whatever I want with it. Here's a little bit of code. There you go. Fairly simple. You basically tell it the start and the stop values, or optionally, no, you don't have to give a start value to ObjectAnimator, but ViewAnimator doesn't know anything about the state of target object. So you basically say, give it a start value and a stop value, or even several values along the way, and it'll create animations in between all of those multi-stop values. You add an update listener so that you can get the animation events so that you can actually do something about the values that are calculated, and then you start the animation. And then there's all kinds of optional things like interpolators or type evaluators or durations. You can change the duration, which is default 300.
And the first line here, when we say ViewAnimator.offFloat, it's one of the built-in animators we have. Because most of the time you're going to animate a float value or an int value. But you can animate, like we said, anything you want. So if you want to animate rectangles, you can create a new ViewAnimator and supply the interpolator and the type interpreter.
Actually, there's an article I wrote probably about a year ago about doing curved path animation. Right now, all of the animation that you get, all the motion that you get through the default animation system is based on linear interpolation. You can go from this XY value to that XY value, and it'll follow a line between them. Typically in a UI, you might want to do something with curved motion instead. I would like to build that into the animation system, but in the meantime, it's actually really easy to use type evaluators and say, well, here's this thing that you don't understand, and here's how to interpret it. And it basically will allow you to animate things along a Bezier spline that you can specify. And the custom type of interpolation, like, yeah, it'd be nice if the animation system handled curved motion for you, but in the meantime, it's actually not hard for you to do this through custom type interpolation instead. So if we take a look at another fantastic demo. So we've got bouncer. It's all about the sheep. So this animation is fantastic. It moves the sheep from up at the top to down at the bottom. Take a look at the code for bouncer.
Why is it called bouncer? It doesn't bounce.
Not yet, it doesn't. Oh, just wait.
I'm discovering the demo with you guys. So.
All right. On draw simply draws the sheep wherever the sheep happens to be. Start animation creates a value animator, and then starts it. And value animator is created down here. So we say of float from 0 to 1. So these are arbitrary values. It has nothing to do with screen size or anything like that. Value animator doesn't care, doesn't know. It's just going to calculate values for you. We add an update listener so that we can do something about those values between 0 and 1 as time goes on. And when we get an update call, we say, okay, this is a long line of code here. Get the animated fraction from the animator, and that's going to be the value between 0 and 1, and multiply it times the size of the screen minus the height of the object. So we're basically going to animate the object from up here to down there. We're going to set the shape Y, which determines the position of the object, and that also invalidates so that we know to redraw things. This doesn't need to be that long, but basically I'm optimizing the invalidate region for the old value, the old position of the sheep and the new position of the sheep so that we redraw the correct area on the screen. We invalidate, we get into on draw, we draw the sheep, we're done. So not terribly interesting, also not terribly bouncy. So we can change that. We can say, for instance, that we would like to actually repeat this thing. So if we run that again, yes. Fantastic. So it's bouncing, but it's still not much of a bounce. It's basically getting the default interpolation behavior, which is an acceleration in and then a deceleration out, which is not typically how bouncing sheeps like to move. Instead, they actually like to bounce. So we can change the interpolation, change the timing curve a little bit. Launch this again. Oh, yeah. Now, that makes no difference on the P2P. Well, it is totally a bounce here. That is a bouncing sheep. I've never seen a better bouncing sheep. Huh?
I hope you can see in the back.
Okay. Everybody move up front. There's like 5 seats free here.
Oh, actually, wait. Okay. Here we go. Much better.
All right.
It's very important that they saw this animation.
So that was ViewAnimator, but what's more typical for people to use, especially for view objects or objects with properties that can be animated, is to use ObjectAnimator instead, which we'll talk about first. So I just want to tantalize you with that. Oh, gee, what is this ObjectAnimator of which they speak?
It's a way to not write code.
It is. Subclass of ViewAnimator, so it's got all the capabilities that we talked about with ViewAnimator, but instead of actually needing to plug in and get the animation update events and then calculate values and then set them on the target objects, you can just have the animation system do that for you. Why do work? So the twist with ObjectAnimator is it will calculate the values because it's a subclass of ViewAnimator, but it will also take the target object and the property or the set of properties that you specify and just deal with the object directly. So it's basically a set it and forget it model. You set up ObjectAnimator with all that information, target object, property, name of property or set of properties, and then the values that you want to animate between. And as long as there are appropriate setters and getters and properties on the target objects that you gave it, then it can do everything else. It knows how to calculate the animated values and it knows how to call the object and change the properties on the fly. So here's how you create an object animator and start it at the same time. So you don't need to plug in with a listener. You just say, here's the animation that I want, go. So we can take a look at Bouncer again. And instead of creating a value animator, we can create an object animator. And we can use the same kind of capabilities there to actually get a bouncing sheep this time. And repeating this thing. And you know what? In fact, let's repeat it more. Everybody wants an infinitely bouncing sheep. Okay, so here's the code for ObjectAnimator, and it's kind of important to see both of these on the screen at the same time. This is the piece that you don't need with ObjectAnimator, right? You don't need to update for listener events. Instead, what you do is you pass in the target object and the name of a property, and it's going to look for a setter for that property. Optionally, it's going to look for a getter if it needs to query the start value. And there's other options here too. We have what we call a property object where it's a little bit more efficient than using a string and using J and I to call into these methods. But essentially, it's the same approach. You basically say this target object, this property, these values, go.
Yeah, and it's important to know that, so here obviously we have to use reflection to make that work, but we're using a few tricks that I think you described in another talk that we gave at Google I/O, where we go through layers of native code instead to call the methods in a much more efficient way than going through the Java reflection classes. So using the object animator instead of a value animator won't cost you anything really. The performance will be the same as with value animator. So don't hesitate. It's, the code is simpler. Chances are you won't have bugs because we'll take care of it for you. And it's easier to read and to write and maintain.
So now we should have an infinitely bouncing sheep. Is that fantastic or what? I mean, it's not an animated kitten, I'll give you that, but it's a bouncing sheep. So the real reason for doing all of this stuff was to give us a more flexible animation system, but we're toolkit engineers. What we want to enable is UI animations. So then we needed the views to actually have properties that we could animate and change over time. So we added some properties to the view class. Specifically, we added an alpha property, which allows you to fade things in and out. Translation X and Y, let's move it on the screen. It's important to note that this is a post-layout translation, which means it does all the layout that determines the width and the height, and then it will apply the translation factors after that. And rotation X and rotation X and rotation Y. So you can rotate in 2D. You can also rotate in 3D if you use the launcher.
3D.
2.5D, 2.75D. If you use the launcher, you'll see some of the 3D effects that we get there. So if you swipe all the way to the left, then you'll get this little tilting blue plane to indicate that you can't go any further in the launcher space. And that's using the rotation Y property specifically. As Romain said, we use J and I to actually call into the setters and getters. This is because it's slightly faster than reflection and doesn't cause garbage to be accumulated that needs to be collected along the way. We actually do a fair amount of work to make sure that we don't cause garbage in your inner loops. So you might want to do some of that as well, but it's nice that at least you can use things like ObjectAnimator without creating little bits of garbage along the way for every frame. So for instance, if you say I want to animate the alpha property, then we will query the target object that you told us about and look for a setter and getter with the name setAlpha and getAlpha, and then we'll tunnel through J and I to get to that method for every animation frame. And also as of 3.2, there's a new property object, capital P property, that's actually a lot more efficient. So you can use view.alpha, where alpha is all caps, and that's actually a static object on view that we will then call into directly, and that's actually much more direct than either reflection or JNI. So that's a more efficient means of accomplishing the same goal.
And you can create your own property objects if you want to animate your own values.
It's sort of a workaround for something that the language should probably have, but it doesn't happen to have, so this isn't a bad way to get around it. Animator Set is just like the old animation set that we were talking about before. It allows you to group objects together and create more interesting choreographies of multiple animations at the same time. You typically don't just want to move the button, but maybe you want to fade it along the way, so you're fading in an object as you're moving it in. Like the activity launchers are both a fade and a scale. So it's nice to be able to group things, and maybe you don't want them to run for exactly the same duration for, starting at exactly the same time, but maybe you want to stagger these things or sequence them. And Animator Set allows you to do that with a fluent API.
I love that last line. It makes me feel like we do smart things at work.
I should just read the bullet directly. And it's a fluent API for building dependency graphs. That sounded great. Let's do that again. All right. So here's a little bit of code so you can see how Animator Set works. The key, one of the nice things really is building up these things in hopefully more of a natural language way. You can use some of the constructors to say, or some of the overall methods to say, play all these things together or play all these things in sequence. But that's a little bit more stilted and not as flexible as you typically want. Instead, you're like, you know what, I want to play this guy, and then I want to play this other thing, or I want to play this animation after a certain duration. And it builds up, as we said, that dependency graph internally, and will run that animation, run that duration, that delay, and then run this other animation. And it sort of allows you to flexibly build up this tree of animations that are going to kick off. And then you start the animator set just as you would any of the child animations. So we can see how to use ObjectAnimator and Animator Set for animating properties. There we go in here. This should look familiar. It's basically based on the old ViewAnimations. I just wanted to show how to do very similar things with the new animation system. Let's fade and move and rotate and scale the buttons and run a group of these things.
Well, the big difference between this version and the old version is that here, since we're animating properties, when we translate the view, when we rotate the view, we actually move the view. So if you translate to the other side of the screen and you touch the button, it will work. Same thing with rotations, like we take into account the rotation in 3D or in the 2D planes to transform the touch events. Yeah, here you go. You do look like a cat when you do that.
All right. And then there's a checkbox on top to load the animations from resources. One of the important distinctions about resources for the new animation system versus the old is the new animation system, when you're using ObjectAnimator, it wants to know the target object. It's going to use an instance of a view and then call the setters and getters on that object. Well, the old animation system didn't do that, right? It didn't need to know about references to instances or anything like that. And resources don't really allow you to do that. They don't know in the XML resource like anything about instances of objects. They're just going to get inflated on the fly. So there's a little bit of code that you need when using resources with the new animation system, because you not only need to load the animation itself, but you then need to supply a target object that it will then be run on. So if we take a look at the code, you can see how these things work. So we declare these animations very similar to the old ones. We create an alpha animation, repeat counts.
Well, actually, it's important to see here that we're using those property objects that we mentioned before. So instead of passing a string, we're passing this instance of the property class that will be more efficient to run the animation. It's also slightly easier to read, I find. And you cannot misspell it.
I bet I could.
Unless you use VI or Emacs.
Okay, translate animation, something very similar. We're passing in, the value that we want to translate to, and then we're repeating and reversing. Oh, this is also new behavior for the new animations. You can actually reverse. The old one, you could repeat an animation, and it would go back to the beginning and then repeat.
No, we had reverse.
We did have reverse, which is fantastic. I thought I added something about repeating.
We had reverse.
It was the same thing. All right. So both of the animation systems allow this fantastic reversing behavior. All right. Scale animation, something very similar. And then finally, the Animator Set. Here's some of the Fluent API to create the dependency graph. I love that phrase. Set animation, we're going to play the translate animation after the alpha animation, but before the rotation animation. And then we're going to play the rotate animation before the scale animation. That sets up these things to sort of follow one after the other. Different ways of doing that. It just happens to be the way that I set it up. And then we could take a look at some of the resources that we're loading from. So here's the fading animation that we have. Property name is going to be alpha. We're going to repeat once. And we're going to reverse on the fly, duration of 300 milliseconds, value to 0. So we're going to, one of the important things to note about the new system is we don't care where you start from, just tell us where you want to go to. And as long as we can find a getter, then we can query the information on the fly to find out where you're starting from. This is really useful if you are, for instance, in the middle of some change and then you want to animate to a new state, then we'll actually pick it up on the fly and go from there instead of popping back to the original value and moving it along the way. Yeah,
and if you create your own custom properties, be very careful. You have those the getter and the setter have to be public methods. The class has to be public, and if you use a tool like ProGuard, make sure that the code doesn't get stripped out. I mean, we've run into that issue a bunch of times at the office where our app developers run into a weird crash in the animation system, and if you look closely at the crash at the stack trace, you notice that the setter and the getter were just missing. And it can be a little difficult to interpret those crashes, but usually if you get a crash with the animation system, it's probably that we cannot find the getter or we cannot find the setter.
So as I was saying earlier, if you are going to use resources with the new animators, there's a little bit of code that you also need. So you can't just start the animation, you actually need to give it a target object to run on because it doesn't know anything about targets in the resource itself. ViewProperty Animator.
I love it. So, we had the old animation system. We have the new one. We had the ViewAnimator, but that was too much code. So we created the ObjectAnimator, and you have this one line of code, but that's still too much. So instead, we created the ViewProperty Animator, and it's an animation system that's very specific to view. So it works only on the base view class. It's very efficient. It's highly optimized. If you try to animate several properties on a view with what we call the VPA, we're gonna batch all those animations together, and we're going to make sure that the invalidates are, there's only one invalidate instead of one per property, and you're going to get much better results. We create the VPA when we were working on, so Honeycomb 3.1, 3.2, our launcher, the home screen, uses a lot of animations, and usually it will do several animations at the same time, like alpha and scale and translate. And while we were profiling the performance of launcher, we noticed that we were spending a lot of time just managing the animations, just sending all the invalidates, setting the properties. And when we created the ViewProperty Animator, we were able to save several milliseconds per frame in our animations. So this is how you use it. You call the animate method on the view. This gives you an instance of a VPA. And then you can chain a bunch of method calls. So here we say translation x200.alpha0. That means you're going to fade the view out all the way to alpha equals 0 and translate it to the right by 200 pixels. Or is it 2? Or is it 2? Is it by or 2? I never remember.
Translation X is 2.
2, okay.
Yes. So a couple of things to note about this too. So we do all of this on one line of code. You could actually have several lines of code. So it could be view, animate, translation X, view, animate, alpha. It's kind of nice when you can string them together. You'll also notice that there's no call to start. There actually is a start method if you really wanted to start immediately and set some values in the current animation frame. But by default, what it does is collects all the information that you've given it in any particular frame, and it'll start everything else on the next frame. So again, it's all about sort of making these things very easy to read and efficient to start and go ahead. And
you will also notice that we don't specify the duration. We have a default duration that works really well for most UI animations. So give it a try, and if that's too long or too short for you, by all means you can go change the duration, but the default one should be good.
The other thing I'd like to point out too is the nature of like the language for specifying this thing, you can think of as basically being, I want this value to be this. It's basically a setter, except instead of just clobbering the value and setting alpha to 0, it is going to animate to 0. So we can take a look at, excuse me, picture viewer, which I was hacking right before this session. So we'll see how this goes.
It better be good.
It's going to be fantastic. I have so many kittens.
I'm watching you.
Picture viewer. You know what? Let's look at code instead. I don't know what went wrong here. Am I missing an import? Oh, it did that. Oh, I love Eclipse. No, it's like, you know what? You copied some stuff. I'm going to copy something in.
I have it running right here.
Yeah, that's the old one.
Oh.
I was going to use new fantastic images, and it's launching. There we go. So
switch to the.
Yeah. All right. As we click on these, we're going to crossfade between these things. So it's just a picture view where we load in these nice, pretty pictures and click one through the other. And I think where are we doing, like previous and next? And okay. So a little bit. So we saw some crossfading stuff before, but as I said, it's a little bit brittle in the transition drawable that you can sort of go between these two images, but what I really want to do is crossfade between a set of them, and the new animation system makes that a little bit easier. So we have all these drawables that we loaded in because we're just kind of hard coding this thing for the demo. That is not the right code. Picture viewer. Draw color. I think. All right. Here we go. So when we click on the image, we're going to animate one image to 0, so we're going to fade out one image view, and we're going to fade in the next image view on the fly. And we do that by saying alpha 0, which animates alpha to 0, and I'll get to that width layer in a second. And then we're going to fade in the other one by saying alpha 1, and with an end action. And the end action is a way of saying, okay, when the animation is done, you could do this in the old system. You needed to add an animation listener and then listen to a particular end callback and then write the code. ViewProperty Animator is all about saving a little bit of code along the way. So we say with end action, you give it a runnable. This is going to run when the animation is over, and it's going to then change the information that it needs to for the image view so that it sets up to run again for the next image that you want to fade to. and then it restores some values as well. So we want to set alpha to 1. Sometimes when you do fades, like we are actually changing the view. So if you animate to a value of 0, that's going to stay there. And it's important to note that. So if you then show that again on the screen, you add that view back into the hierarchy and it's still got an alpha value of 0, then you ain't going to see it. So typically you want to restore values when you're done. With layer is an important call. The pattern for a lot of animations when you have complex views or complex view hierarchies is during the animation it's nice if you can tell us that this thing is not going to change, and the best way to do that is to say with layer, and then instead of redrawing that thing on every frame, we're going to create a texture. We're going to put all that information into a texture, basically a bitmap on the GPU, and all we're going to do is copy that thing around. Extremely efficient. And you can do this with listeners in the original version of ViewProperty Animator and certainly ObjectAnimator. You would do this with listeners, and you would set up the layer at the start, and then you would listen in the animation end callback, and you would say, okay, and when you're done, disable the layer. ViewProperty Animator, we just have this one method called that says with layer. We build the layer for you. When the animation is done, we tear the layer down.
And speaking of set alpha, so in the second part of this talk, we're going to talk a little more about set alpha and what are the performance implications. And there's a lot to know about set alpha.
We saw some codes. Here's how you would do a fade, yes. Okay, layout transition. This is the one shot, one line of code. Let's get some interesting container changes. When you add views, when you remove views, or even when you change the configuration of the current container. And it will animate not just the container itself, but also the view hierarchy above it, because things tend to react all the way up the tree. So yeah, let's take a look at some code again. What was, this one is what, layout trans changing?
Mm-hmm. Yeah.
Okay, actually let me show you. So the key way to start this thing off is either in XML or in code. In XML you say animate layout changes equals true on a layout. Or in code you say here's a new layout transition and set that as a layout transition on the object. There are some options here. If you look in API demos, you can create custom animators. You can do all kinds of stuff with the layout transition. However, in general, we kind of do the right thing, and you probably just need this one line of code to enable and disable
By
this
default,
thing.
we're going to use fade and move animations. But if you want to do something, fancier like 3D rotations or whatnot, you can do it.
Okay, so if we take a look at layout trans changing, this has a bunch of custom views in here. So by default, oh, geez, it's really hard to see the colors. I should not use
maybe
pastels.
We can get help from our friend.
Yeah.
Let's see. It's hard to target the buttons.
Much better. Okay.
Thank you.
So by default, what you get is no animation. So this is a custom view that simply paints a background color, this randomly generated background color in OnDraw. It draws that color, and it has a certain size, right? It's basically just a way for me to pop up a colored rectangle. When you add another view, it'll add another rectangle in there. Meanwhile, its container has more and less children. Wouldn't it be nice if we could add in as these things come in and go away? So we can go into, say, the resource for that container and say animate layout changes is true. Run this thing again.
Let's try again.
So as we add and remove, you can see we're sliding things out of the way to make room for it, and then we're fading in the new view. Or when you delete on one of these things.
I have too many fingers. Oh, it's too hard. You try.
Okay, here we go. Press this other button to delete, and we fade the thing out, and then we slide around the other objects in the container to
And if you tap the
compensate for it. Meanwhile, if we tap the object, this basically tells the view to be larger or smaller. You'll notice that's still kind of disruptive, right? It just pops into its new size. And this was the original behavior of layout transition, was just to react to the add, remove, or the set visible operations that are going on in the container. So as of Jelly Bean 4.1, we added a new capability called changing. So we can run this thing again. This listens to layout changes on the object, and any layout change in the container, it will react to then. So not only adding and removing, but also.
Okay, and now when I type an object.
So it listens to a layout change. It says, okay, here's all of my children, their sizes and locations now, and here's where they're going to be after this layout change kicks in. It takes the before and after, it creates animations for all the objects that change along the way, and then it starts the animation and animates them along the way. So this is kind of cool. One of the hidden reasons that this works well is because we don't run layout on the fly, and it's kind of a tip for you for animations in general. Try not to run layout because that's actually a really expensive operation on the entire view hierarchy. So anything you can do to optimize around that is a good thing, and layout transition does that by default. So it does true measurement before to figure out where things are, and does the measurement after to figure out where they're going, and then all it does is animate the layout properties left, right, top, bottom, so that it can change these things on the fly instead of running layout every single time to get there. So here's the new property that we saw in code. We basically enable this new transition type. It's not on by default for compatibility reasons, in case that would shock anybody by being enabled. But it's very easy to enable it, just one more line of code. It's very good for specific use cases. I wouldn't litter it throughout your code because you may get some unexpected things happening. Deeply nested hierarchies that are all trying to animate layout changes at the same time, they may have conflicting information, and that may not be the effect that you're looking for.
Specifically, do not try to use layout transition with list view, for instance. List view is this virtualized container, and layout transition will not do exactly what you want.
We talk about list view a little bit more in the second half of this talk today, and you'll see some of the things that you can run into there with recycled views. Another thing that it won't handle is, so it'll animate the entire parent hierarchy. So if this container is animated and ends up getting larger, well, it'll animate, and its parent container will also animate, so you get this nice flow. But if there's a sibling of one of those parents, they may just pop to their end size. They're not going to react in an animated way. It's kind of an optimization because you don't want us crawling throughout the tree on every single frame to handle all this stuff. But just be aware of that if you start using it. Animation tips. We're going to rip through these pretty quickly. Performance matters. In particular, like inner loop performance matters a lot. Like everything you're doing on every frame of the animation is terribly important. We spend a lot of time to make sure that we're not doing a lot of garbage creation on every frame. We're also not doing a lot of, wasting a lot of time with horrible amounts of logic on every frame, just to make sure that your inner loop isn't slow. And you should do the same thing, particularly for animations, because we're trying to run these things and get nice fluid animations. 60 frames a second means 16 milliseconds per frame. Every millisecond counts, right? For graphics rendering in general, but particularly for keeping smooth animations. Anything that slows it down, that crosses that barrier once, is going to cause a noticeable hiccup on the screen. Avoiding allocations is good in general. The VM is great, GC is wonderful, it's all magical, but if you get a GC in the middle of your animation, you may notice it, especially if it's collecting things like really large objects. If you're allocating bitmaps on every frame, which I've seen some applications do, like this huge object, we're going to load another new bitmap on every single frame. Well, that adds up. Sometimes you'll GC on every frame and it'll take several milliseconds and you'll get really stuttery animations. Or sometimes, you'll be fine for a little while, but then in the middle of the animation, GC will kick in and you'll get a noticeable hiccup, and it's a bit jarring. Avoid layout on every frame. As I said before, that's a lot of processing time on every frame. It's nice to not have to do that when you're trying to have a smooth animation. Make your animations to the point, right? Don't get so entranced by your own wonderful animation that you actually make your user sit through it every single time. We don't want the opening window effect where it's doing this beautiful unroll and the user has to go through that every time they use your activity. Right? Instead, just make it short and purposeful. Have a quick fade, transition the user, but transition them very quickly. Use layers, as we said before. This is a rendering technique to allow us to do our job of drawing these things much faster than we could otherwise. If they're complex view hierarchies or complex views, then consider using a layer temporarily just during the animation so that we can actually speed up the transition for you. Here's how you set a layer. You basically tell us to use a layer type hardware on this thing. And then with ViewProperty Animator, you just tell us to use with layer. And then we do all the underneath work for you. And an important property that we noted, that we added in, I think it was Jelly Bean 4.1, is the ability to scale animators. This already existed for window animations and transitions, and we added it to animators. The first thing, when anybody brings me a bug, the first thing I do to debug the animation is extend the duration, either by scaling that, or if I can get to the code, I'll just change the duration so that I can actually see easier what's actually going on the screen, because your eye has a really hard time tracking things that are only 200 milliseconds in duration.
So here I launch settings, and in the developer options category, you can change the scale of animation. So you have animator duration scale, that's for the animation, the property animations we just talked about, and you can go from completely disabling animations to all the way to slowing them down by 10x. You can also apply a similar scale to transitions and to window animations. So if you're debugging your animations, go to developer options, make them go slower, and you will be able to see more frames and understand what's going on.
I think you need to kill and launch your activities.
Yeah.
After you change those properties. Another technique that we use a lot is recording these things, either with a high-speed camera or sometimes even just a normal camera. Again, it's kind of hard for the eye to track things, and if there's a complex choreography of animations going on, you may not quite understand what's happening. It helps so much to be able to actually record this thing and then just step through frame by frame and see what's going on. And this is with a camera, but there's also relatively cheap recording equipment. We have an HDMI recording system that's like a couple $100 on Amazon. Really helps in debugging some things that are going on. And finally, use the tools. There's some fantastic tools that we ship with, like Allocation Tracker, Trace View, SysTrace that we'll talk about a little bit later, Printline. All of these things help in figuring out what you're actually doing when you're rendering and whether there's a bottleneck that you weren't aware of, what you're allocating along the fly and shouldn't be. Heap, what is it, Hat or JHat, or also the Matte plugin for Eclipse. All help in figuring out whether there's leaks, there's garbage that you're creating that you weren't aware of. Use the tools.
So we have a few toys to give away. And I just wrote a small application that will randomly pick a seat in the room, so hopefully that will work.
22 by 36 is the room.
22? Okay.
22 rows, 36 seats. There's a seat number, and they start at 1 to 36.
Number 4 and row 20, so someone in the back. Can you count the rows?
Oh, crap.
You go find them.
What was it?
4, column 4, row 20. Run! Run, Chet, faster. You're gonna die if you keep going like this. He's too old for this.
4. None. Nobody there.
Damn it. So that's why we need to pack the room. Okay, column 15, row 12.
All right.
Colin, we're running out of time.
I don't know what row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, look at that. 12.
15.
15. 13, 14, 15.
No. Row 12, column
Row
15.
12.
Row 12, seat 15.
Hey! There you go.
Okay. Okay, 26, row 6. Row 6. Where's row 6? I'll go. 1, 2, 3, 4, 5, 6. 26. Well, okay, 27. You get it. I don't feel like running more. Just press Command R. That's an easy one. 10, 5. Row 5. Column 10. Wait, seat number, row 5,
row 5.
Seat number 10.
Row 5.
Seat number 10.
10. Yes. 10. Sorry. Okay.
Almost there. Okay, row 10.
Seat
13. course, nobody cares about the little droids. They want this.
9, 10, 13.
Yeah.
There you go. Wait, 11, 12, 13. Yes. All right.
Okay, row 12. No. Row 12, seat 11. Next talk, I'll be the guy running. So row 12. And if you don't like the random numbers, you can blame the JDK.
12. Seat 11.
Seat 11.
Congratulations.
There we go.
All right.
All right, so let's take a 20 minutes break. It's what, 11 right now, so let's be back at 11:20. And then we'll talk about tips, optimizations, performance, and a few tools.